The Q function is an important function in communication systems for calculating probability of error. Most of what we need for the Q function already exists by way of the continuous CDF built-in subVI. CDF is the cumulative distribution function. And specifically when we have this configured for the normal distribution, which is another name for a Gaussian, we end up with a calculation that's based on an input parameter x, a mean and a standard deviation, such that we get the area under the curve of that normal all the way from minus infinity to the present value x. Now the default values for mean and standard deviation are 0 and 1. I was just illustrating standard deviation a moment ago. Now what we need for the Q function is really just the complement of what we get here. If we apply x and get the area under the curve from minus infinity to x, then we also recognize that the total area is 1. Therefore, we can subtract the result here from 1, and that will give us the right-hand tail. So essentially, what we're trying to calculate for the Q function is the area under the Gaussian curve from x all the way out to positive infinity. Alright, let's try some sample values and confirm that in fact the calculation is being done properly this way. Now if x is 0, then you're exactly right in the middle of the curve. So we expect to see half of 1, or 0.5, which we get. Let's try some other values that are pulled from a table of Q function values. And I have some tabulated values for x, 1 equals 1, 2, and 3. And I think you'll find that if you compare the tabular results to what we're getting from this subVI, everything looks fine. And there you have the Q function.